Welcome back everyone to another video here on the Unknown Code YouTube channel. Today we are looking at LeetCode problem 724, find pivot index. Now what this problem states is it's going to give you an integer array called nums and we want to calculate this thing called the pivot index. Now what in the world is a pivot index? Well, luckily for us, LeetCode wants to tell us. So the pivot index is the index where the sum of all numbers strictly is important here, to the left or strictly to the right is equal to the same value. So basically what we want to do is we want to take all the numbers to the left of an index and all the numbers to the right of an index, sum them up and see if they're equal to the same thing. Another important thing to know is that if the index is on the left edge, aka if the index is 0, then the sum on the left would be equal to 0. And then if the index is on the right edge, or basically meaning if index is equal to nums.length, then that is also going to be equal to 0. What we want to go ahead and do is return the leftmost pivot index if none exists. So basically if there's no index which the left side and the right side are equal, then we're going to go ahead and return -1. So to go ahead and clarify this, let's go ahead and take a look at some of our examples. For example number 1, our nums array is going to be equal to 173656. And what we're going to try to look for is some number in the middle of this array where each side is equal to one another. In this case, it's going to be index 3, because if we take away index 3, 0, 1, 2, 3, 4, 5, we take away 3, which is equal to 6, the sum of 1, 3, 7, and the sum of 5, 6 are both equal to 11. So that means that the output is going to be 3. So let's take a look at the second example. For example 2, our input is going to be nums of 1, 2, 3. With this index, if you start on the left side equal to 0, left would be equal to 0, and right would equal 5. For index 1, left would equal 1, and right would equal 3. And if you did index 3, left would equal 3, and right would equal 0. So there's no index which allows us to do this. So we return -1. All right, let's go ahead and take a look at the third example. For the third example, our nums is going to be equal to 2, 1, and -1. And whenever our index is equal to 0, our left is going to equal to 0, and our right is going to be equal to 0. So this means that we found our pivot, so we can go ahead and just return 0, and we're good to go. So that's what that looks like. Let's go ahead and take a look at our constraints. Our constraints for this one are pretty straightforward. Firstly, 1 is less than or equal to nums.length is less than or equal to 10 to the 4. So this is just saying the array length is between 1 and 1000. So nothing too crazy here. If you needed to do a double for loop or something like that, you could definitely get away with it without running out of time. The next one is also pretty interesting, and it's -1000 is less than or equal to nums of I is less than or equal to 1000. So this means that the values inside the array are between -1000 and 1000. So this might make some situations like we saw previously where it ends up being both of the values equal to 0, or they're both negative or something along those lines. So there's something that you can't actually rule out. So once again, the goal is to go through and loop through this array, keeping track on the total count of all the elements on the left side and all of the elements on the right side of a so-called pivot point, and then go ahead and return the leftmost index that's called the pivot point that we find where both sides are equal. This problem can actually be a little bit confusing when you're first starting out, because whenever they say strictly left and strictly right, they mean that the index you're currently on does not count at all towards either side's count, and this is why the sum of left of index 0 is equal to 0, and the sum of right of the index of length -1 is also equal to 0, because there's nothing to the left or right. The ultimate solution of this problem is going to take two parts. So first we need to go ahead and find the total sum of all the elements in the array. Then we want to loop through and determine when the left side minus the current index minus the total sum is equal. Then we can go ahead and return that value. So let's go ahead and take a look at the pseudocode and walk through the example. We want to start out by saying for each value inside nums, add that current value to total. Then after this loop, we once again want to say for each value in nums, if the left sum is equal to total sum minus left minus current value, we want to return the current index. Otherwise, we're going to continue. And if we make it to the end of this loop without returning anything, we'll return -1. Let's go ahead and take a look to see if this is actually going to work or not. For example, we are going to go with a pretty long example, so I'm going to try to make it all fit. We're going to go with nums equal to 173656. So we need to go ahead and start the first loop with I equal to 0, our nums of I equal to 1, and total equal to 0. So we want to go ahead and say total plus 1. 1. For I equal 1, nums of I will be equal to 7, and total is equal to 1. So we're going to say total plus 7. For I equal 2, nums of I is equal to 3, and total equal to 8. Total plus 3, I equal to 3, nums of I equal to 6. Total is equal to 11. So total plus 6, I equal to 4, nums of I equal to 5, and total is equal to 17. So now let's say total plus 5, I equal to 5, nums of I equal to 6. Total equal to 22, total plus 6, and then that's the end of the loop. Total will be equal to 28, and we go ahead and start the next loop. For the next loop, something we need to know is that the value of right side will be equal to the total minus the left value minus the current value. So, okay, let's go ahead and start the next loop. For I equals 0, left is equal to 0, and current is equal to 28 minus 0 minus 1. So left is equal to 0, current is equal to 27. 0 does not equal 27. So we just continue. So we go ahead and add the current value to left. For I equal 1, left is now equal to 1, and current is equal to 28 minus the value of left, which is 1, minus the current value, which is 7, which equals 20. Once again, 1 is not equal to 20. Now we're going to add left plus 7. Now I equal 2. Left is equal to 8. Current is equal to 28 minus 8 minus 3, which equals 17. So once again, 8 does not equal 17. So we'll add left plus 3. For I equal to 3. Left is equal to 11. Our current is equal to 28 minus 11 minus 6, which is equal to 11. And now 11 is equal to 11. So now we want to go ahead and return the index of I, which is equal to 3. And that is how that works out. Let's go ahead and hop onto LeetCode and code this out. Here in LeetCode, we're going to start with an int left equal to 0, and an int total equal to 0. Then we're going to say for int num and nums total plus equal to num. Then we'll say for int I is equal to 0. I is less than nums dot length and I plus plus. And we're going to go ahead and say if left is equal to total minus left minus nums of I, like we did inside of our pseudocode. If this is the case, we'll go ahead and return I. Otherwise, we're just going to go ahead and say left plus equal to nums I. Then if we do not have any output from this for loop, we'll return -1. Let's go ahead and submit this. Fingers crossed, no typos as always. And just like that, we get a 1 ms runtime that beats 100%. We also beat 85% of memory complexity, so that's pretty good as well. If you guys did find some value in this or find it interesting, please leave a like, comment, and subscribe. I'm uploading videos like this every single week, as well as my Let's Build Twitter series. I appreciate you all for watching. As always, I'm Ethan, or Unknown Coder. I'll see you guys in the next episode. Have a great day, everybody.